Cancer is brutal. It begins so quietly that no one ever notices the start of it. Somewhere deep inside the body, a single cell takes a wrong turn. Then another cell follows, and another, and then, one ordinary day, a doctor sits across from you and utters 3 words that rearrange your entire life. You have cancer. It steals years. It steals people. It hollows out families from the inside, leaving rooms that used to be full strangely quiet. It does not spare the young, and it does not spare the old. It does not pause to consider how much you still had left to live for. Cancer is one of the most merciless forces in all of nature. And the truly unsettling part is this: it has been with us since the very beginning of who we are. Most people assume cancer is a disease of modern life, something born from processed food, pollution, and a sedentary, screen-lit existence. And while those factors absolutely play a role, the deeper truth stretches back much, much further than anyone expects. In 2016, inside a cave in South Africa, researchers uncovered a single fossilized foot bone belonging to an ancient human relative, a species of early Homo that walked the Earth roughly 1.7 million years ago. Under examination, that bone revealed unmistakable signs of osteosarcoma, an aggressive and malignant bone cancer. This was not a fracture. It was not an old injury. It was a tumor, growing inside a creature that existed long before our own species ever took its first breath. The same study uncovered something else, a benign tumor in the spine of a skeleton from roughly the same era. Scientists refer to these abnormal growths as neoplasms, and discovering them in fossils nearly 2 million years old tells us something genuinely profound. Cancer is not new. Cancer is ancient. It is older than agriculture, older than cities, older than written language itself. Here's the complication though. Cancer mostly takes root in soft tissue organs. Skin, blood, and soft tissue does not fossilize. It breaks down and vanishes over centuries, leaving almost nothing behind. What survives, instead, is bone. So what we find scattered through the fossil record is only the faintest trace, a tiny fraction of how much cancer likely existed throughout history. Researchers call this gap a preservation bias. We are only seeing the rare cancers that happen to leave a mark on something hard enough to last millennia. This is exactly why mummies have proven so valuable to researchers. Unlike fossils, mummies preserve soft tissue, and that preserved tissue has told us an enormous amount. Using CT scans and other advanced imaging techniques, scientists have identified tumors hidden inside Egyptian mummies that are thousands of years old. In one notable study, researchers scanned 137 mummies and found clear evidence of cancer in a number of them. Taken together, the fossil record and the mummy record paint a remarkably consistent picture. Ancient humans dealt with cancer on a fairly regular basis. But we don't have to rely solely on bones and preserved bodies. Ancient civilizations actually wrote about this disease too. The Edwin Smith Papyrus, an ancient Egyptian medical text dating back to roughly 1600 BCE, includes a description of bulging tumors of the breast. Strikingly, the text bluntly states that there was no treatment for them, a frank, almost heartbreaking admission from a physician writing nearly 4,000 years ago. Centuries later, around 400 BCE, the Greek physician Hippocrates gave the disease the name we still recognize today. In spirit, if not in exact wording, he used the term karkinos, the Greek word for crab, because the swollen blood vessels surrounding a tumor reminded him of a crab's outstretched legs. The Roman physician Celsus later translated that word into Latin as cancer, the very word we continue to use more than 2,000 years later. So across thousands of years and multiple, entirely separate civilizations, people observed this disease, documented it carefully, and tried desperately to understand it. They simply didn't yet know what was causing it. To understand why cancer is so ancient, it helps to understand what cancer actually is at its core. It begins when a single cell picks up a mutation, its DNA gets damaged, or copied incorrectly during division. Most of the time, the body's internal repair systems catch these errors and fix them before any harm is done. But occasionally, a mutated cell slips past that correction system entirely. It begins dividing without restraint. It accumulates into a mass. Eventually, it invades the tissue around it. Mutations are not some rare anomaly, they happen naturally. Every single time a cell divides, they are woven into the basic mechanics of life itself. The more cells an organism has, and the longer that organism lives, the more opportunities exist for a mutation to slip through unnoticed. Every living thing made of dividing cells carries this risk. Dinosaurs developed cancer, Ancient fish developed cancer. Even trees, in their own way, can develop cancer. So did ancient humans actually get cancer less often than we do today? Honestly, probably yes, but not for the reasons most people assume. The single biggest factor is lifespan. Most ancient humans simply didn't live long enough to develop it. They died young, from infection, injury, predators, and famine. The average life expectancy for a prehistoric human hovered somewhere between 25 and 35 years. Cancer, by contrast, takes time to develop. Most cancers don't even appear until well after the age of 50. If you die at 30 from a lion attack or an untreated tooth infection, cancer simply never gets the chance to take hold. Ancient humans also faced an entirely different set of risk factors than we do. They didn't smoke tobacco. They weren't exposed to industrial chemicals. They ate whole, unprocessed foods, and their bodies were in near constant motion. All of these factors would have lowered certain cancer risks considerably, but they carried risks of their own. Smoke from cooking fires irritated their lungs over a lifetime. Chronic parasitic infections and ongoing inflammation are known to promote certain cancers. Unprotected sun exposure raised their risk of skin cancer. In other words, ancient humans were not living in some cancer-free paradise, they were simply dying of other things first. So why does it feel like cancer is everywhere today? Part of the answer is simply that we live so much longer now. Modern medicine has eliminated or dramatically reduced most of the threats that used to kill people young. As a result, millions of people now live well into their 60s, 70s, and 80s, precisely the age range when cancer is most likely to develop and, crucially, to be detected. Detection itself is the other half of the story. We now possess technology capable of finding a tumor no bigger than a fingernail buried deep inside the body. Ancient physicians, by contrast, could only diagnose what was visible on the surface or felt by hand. Countless internal cancers throughout history went completely undetected, hidden until death. And yes, certain modern lifestyle factors genuinely do increase cancer risk. Tobacco use is directly linked to cancers of the lung, throat, and mouth. Processed red meat consumption is tied to colorectal cancer. Obesity is connected to more than a dozen distinct cancer types. Unprotected UV exposure causes skin cancer. These are real, measurable risks of contemporary life, but they are layered on top of a disease that has existed since long before any of these modern habits did. Understanding that cancer is ancient actually helps scientists today in very tangible ways. If cancer has accompanied multicellular life for millions of years, that means it is woven deeply into the basic fabric of how complex organisms function. Researchers are now studying why certain animals appear to have unusually low cancer rates despite their size and longevity. Elephants, for instance, carry multiple extra copies of a cancer-suppressing gene called TP53. Scientists are studying that gene closely, hoping it might one day inform new human cancer treatments. The fossil record offers something else, too, a way to track how cancer rates have shifted across deep time. By comparing ancient bone tumors to the tumors we see in modern patients, researchers can study how certain cancers evolve and which environmental conditions seem to trigger them. Cancer, in the end, is not simply a medical problem to be solved in a lab. It is an evolutionary puzzle stretching back millions of years, and understanding its deep, ancient history is very much part of solving it. A 1.7 million year old bone, a tumor. A creature that lived before language, before fire, before anything we would recognize as civilization, and cancer was already there, waiting. It is one of the oldest adversaries the human lineage has ever faced, and for the first time in that long, brutal history, we finally have real tools to fight back.